The following from Fall 2011 Math 27 Test 3, number 2. According to Crime in US States, the publication of the FBI, the mean value loss to purse snatching was $356 in 2008. For last year, instead of 12, it's supposed to be 11. 11 randomly selected purse snatching offenses yielded the following values lost to the nearest dollars. Those are the data. Okay, at 2% significance level, test the claim that the mean value lost to purse snatching has decreased from 2008 mean, which means only decreased from that $356. Now assume that the population has normal distribution. Now we are doing hypothesis testing here. We need to test the claim. So we see that the n equals to 11. Okay, and now let's compute what is x bar. That will be sigma x over 11, right? Which, if you compute, when you add all of them, let me do it here. This one, it will take some time. This is 446. The reflection and the glare. Plus 296 plus 386 plus 189 plus 293 plus 261 plus 250 plus 229 plus 372 plus 290 plus 454. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 data. When I add them, that will be 3,466 over 11. If I divide by 11, I will get 315.09091 if I round it to 5 decimal places. Now then, the next thing I will compute is the S squared, the sample standard deviation, which according to our formula, this is n square root sigma x squared minus sigma x quantity squared over n times n minus 1, which is 11 times sigma x squared, which I will compute later, minus 3466 squared over 11 times 10. Okay, now what I will do now is to compute what is sigma x squared. I hope you remember what is sigma x squared. Sigma x squared is basically the sum of all the squares of these numbers. Okay, and 446 squared plus 296 squared plus 386 squared plus 189 squared plus 293 squared plus 261 squared plus 250 squared plus 229 squared plus 372 squared plus 290 squared plus 454 squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This gives me 1168760. Okay, now let's compute that. Times 11 minus 3466 squared. I get 843,204 over 11 times 10. Now I divide this by 110. That will give me 7665.49091, which implies that's the sample variance, right? The sample standard deviation will be the square root of that, which is 87.55279. Okay, now let's start with the hypothesis testing process. Step 1, the claim. The claim is that the mean value loss to purse snatching has decreased from from the 2008 mean. Okay, step 2, the hypothesis. Okay, or statistical hypothesis, the H0 and H1, the mu here, that they want to say the mean is already decreased from the 208 means, which is less than 356, right? And therefore the null hypothesis will be the competing hypothesis. Okay, now from the claim we know that's actually follow the alternate hypothesis. Now step 3, the test statistic. Notice that we are actually doing hypothesis testing, test the claim on mu, but we don't know what is the population standard deviation. What we know is the sample standard deviation. That way we will see that we are using t. Okay, we are using t, and that will be 315.09091. That's the x bar minus the supposed mu, which is 356, over the standard deviation of the sample. That's 87.55279 big over square root of 11. Okay. Now, if I compute using my calculator, that will be 315.09091 minus 356 divided by that standard deviation multiplied by you get 315.09091 minus 356 divided by 87.55279, and then multiplied by square root of 11. This is what I get. The t star equals to negative 1.55. That's the t star. And now the critical value, the t critical. Notice that we are doing a one-tail test, and let's say this is my t distribution. I am doing a one-tail test on the left tail. Okay, this is the t critical. If I see my t distribution, the degree of freedom is 10. The 2% significant level on one tail, we can't really tell, huh? The area in one tail is between this one and that one, right? So we can't really tell what's the number, but we can tell that the t critical will be between, let's see, between 2.764 and 2.228. 2.228 and 2.764. Of course, then, oh, I'm sorry, I need to do it in negative. So TC will be negative 2.764 to negative 2.228. Okay, now notice that here we do not find the precise critical value for T, right? But we can approximate which region it is. Let's take a look again. The degree of freedom is 10. The area in one tail, is between 0.01 to 0.025, right? So the T critical should be between these two numbers in negative though, using negative. okay, using negative. Guess what I get now? In step 5, however, you see that where is my t star? My t star is here, negative 1.55. Right, my TC is between is less than negative 2, so you will see that my informal conclusion is we will informal conclusion this is accept null hypothesis, or in other words, you reject alternate hypothesis. Okay, now let's write the formal conclusion. Formal conclusion, we say that at 2% significance level, the sample data, or the sample, is not sufficient to support the claim. Well, because the claim happens to be on the alternate hypothesis, right? Now, to support the claim that the mean value loss to purse snatching has decreased from the 2008 level. Okay, this is from fall 2011, Math 227 test 3, Melanie's test. This is Melanie's test.